Hello students, welcome to another class. In this class, we are continuing our study on the chapter number 2, that is solution, and today we are going to discuss about the vapor pressure of liquid solutions. Liquid solutions means the solutions when the solvent is liquid. Solvent must be liquid for liquid solutions. Solute may be very, solute may be liquid, may be solid or may be gas. But the solvent must be liquid. That is, we know that the nature of the solution depends on the nature of solvent. If the solvent is liquid in nature, then the solution is also liquid in nature. If solvent is solid, then solution is also solid, and if the solvent is gas, then the solution will also be a gas. Okay. So, in liquid solutions, we will discuss about two liquid solutions. First one is liquid solutions. Here, the solute and solvent both are liquid, and the second one is liquid solid solutions, where the solvent is liquid and the solute is solid. So the first one is vapor pressure of liquid solution, and the second one is vapor pressure of liquid solid solution. Here under the bracket we have written volatile, and in case of solid we have written non-volatile. Volatile substance means the substance which can evaporate. Volatile means substance which can evaporate easily. Okay. The substance which can evaporate. For example, if we keep water outside, what happens? It evaporates and the amount of water in the container reduces. Non-volatile means the substance which cannot evaporate. For example, if you keep sugar outside, what happens? Nothing happens to it. The amount will not change. But in case of camphor, what happens? If we keep camphor outside for a long time, the size of the camphor reduces. That means camphor is volatile. Okay. So first of all, we will discuss about the vapor pressure of liquid solutions. Then we will discuss about vapor pressure of liquid solid solutions. The first one is important. Okay students, now let us see the vapor pressure of liquid solutions. For this, let us consider two volatile liquids, 1 and 2, and P total with the total pressure of the solutions, and P1 is the partial pressure of liquid 1 and P2 be the partial pressure of liquid 2. And similarly, X1 is the mole fraction of liquid 1 and X2 be the mole fraction of liquid 2. What happens? In a beaker or in a container, we add liquid A and liquid B. It is a mixture of two liquids. Okay? So here the total pressure of the liquid is P total, and individually the partial pressure of liquid number 1 is P1 and liquid number 2 is P2. Okay. After this, according to route law, the route law is very important. Okay, according to route law, what it says, for a solution of volatile liquids. Volatile liquids means what? The liquid which can evaporate. So, for a solution of two volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction. That means, if in a solution, this is our solution, here two types of liquid are present, namely 1 and 2. If the amount of 1 is high, if the amount of 1 is higher than the amount of 2, then its partial pressure is also high. That means partial pressure is directly proportional to mole fraction. Mole fraction means amount. If the amount of A is high, then its partial pressure is also high. And if the amount of A is low, or if the amount of 1 is low, then its partial pressure is also low. So partial pressure is directly proportional to mole fraction in the solution. So for a solution of two volatile liquids, partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in the solution. Okay, मतलब क्या होगा, एक सॉल्यूशन लिया है जिसमें अगर अल्कोहल और वाटर लिया है, अगर अल्कोहल का अमाउंट ज़्यादा लिया है तो उसमें क्या होगा, अल्कोहल का प्रेशर भी ज़्यादा होगा. अगर वाटर का अमाउंट ज़्यादा लिया है तो वाटर का पार्शियल प्रेशर ज़्यादा होगा. ओके, ठीक है. तो इससे हम क्या लिख सकते हैं, देखो. So you can say that, or you can write that P1 is directly proportional to X1. P1 is what? Partial pressure of liquid 1, and X1 is the partial pressure of, X1 is the mole fraction of liquid 1. Okay, I am going to write this one. So we can write, so for liquid 1 we can write X1 is P1 is proportional to X1, or we can write P1 is equal to P1 not X1, when P1 naught is the vapor pressure pure liquid 1. P1 naught is what? The vapor pressure of liquid number 1, and this one is partial pressure. Now for liquid 2 we can write P2 is proportional to X2, or P2 is equal to P2 naught X2. Similarly, P2 naught is the vapor pressure of pure liquid 2. pressure is the sum of partial pressures of the liquid present in the solution. Here two liquids are present, 1 and 2, and their partial pressures are P1 and P2. So the total pressure will be P1 plus P2. So what is from the equation number 1 and 2, write equation number 1 and it is equation number 2. What we can say, P total equal P1 naught x1 plus P2 naught x2 from equation number 1 and 2. Now let us before proceeding to the equation, let us see something. The total mole fraction, okay, the total mole fraction of the liquids or substance present in the solution, their sum is 1. That is, in this case there are two liquids, 1 and 2 are present, and their mole fractions are x1 and x2, and their sum, always remember the sum of mole fraction is always 1. If suppose there are three liquids or three components, namely 1, 2, 3, and their mole fraction is x1, x2 and x3, then their sum, that is x1 plus x2 plus x3, is always 1. So remember, the sum of mole fractions of component is always 1. So we continue. Total again, P total equals again P total equals P1 naught 1 minus x2. I will tell how it comes. Again P2 naught into x2. Right here, since the sum of mole fraction is always, since the sum of mole fraction is always 1, so here the mole fractions are x1 and x2 and their sum is 1, then definitely x2 is equal to 1 minus x1. So we write this. Now after P1 equal minus P1 naught x2, P2 naught x2, take x2 common from this 2, what happens? x2 equal P2 naught minus P1 naught. So P total, this is P total, total partial pressure or total pressure. mole fractions if y1 and y2 are the mole fractions at the vapor phase. Y1 is the mole fraction of liquid 1 and y2 is the mole fraction of liquid 2. Then we can write then P1 equal P1 equal y1 into P total and P2 equal y2 into P total. You should remember the equations. In the next class we will solve the numerical related to these equations. Okay. Now we are going to see a plot of mole fraction versus vapor pressure. Okay students, so let us see the figure. What happens? From left to right, the mole fraction of component x1 decreases. Here the mole fraction of component 1 is 1 and here liquid 1, the mole fraction of liquid 1 is 0. So when here we can see that the vapor pressure of x1 is very high and gradually, since the mole fraction is decreases, the value of P1 is also decreases, and when the value of x1 is 0, P1 is also at the 0. Similarly, in this case we can see that if here x2 is 1, the P2 at its highest place, and gradually here x2 decreases. That means mole fraction of component number 2 decreases. Similarly, P2 is also decreases. तो क्या होगा? X क्या है? Mole fraction of liquid 1 और हम लोग पहले पढ़ा था क्या होता है? Proportional to partial pressure is proportional to mole fraction. तो इसमें क्या हो रहा है? Mole fraction ज़्यादा है तो partial pressure भी ज़्यादा है. इसमें मोल फ्रैक्शन कम हो गया तो पार्शियल प्रेशर भी खत्म हो गया. सिमिलरली क्या आता है वो ये तो इसको आ सकता है प्लॉट किया मोल फ्रैक्शन वर्सेस वेपर प्रेशर का. इसमें क्या होगा? मोल फ्रैक्शन जितना ज्यादा होता है उतना ज्यादा क्या होगा वेपर प्रेशर, और मोल फ्रैक्शन जैसे डिक्रीज होगा वेपर प्रेशर भी डिक्रीज होता है. Okay, thank you class. On the next class we are going to discuss or going to solve some numericals related to these equations.